Hi, Todd Dunn here on January 28, 2020. Today I'm here to talk about one of the components in my home solar battery backup power system. Today I'm going to start by talking about this little gadget right here, which is the Schneider Conext SW 4024 inverter. Now this inverter has a nominal 4,000 watt output. However, that's its surge output for 30-minute surge, and its continuous output is 3,400 watts. It also has one other distinctive feature, and that is that it has what's called split phase output. In other words, it doesn't put out just 120 volts AC, it puts out 240 volts AC in two legs, and that allows me to run 240 volt appliances, which in my case is my well pump. So I had to have a split phase output inverter to run the well pump. Anyway, so what I want to do is just talk a little bit about some of the details of installing this inverter, some of the not really problems, but kind of issues I ran into, and how it's been working for the 2 months that I've had it in operation here in the house. So let's get going and start looking at things. I want to start by talking about the physical installation of the inverter. First off, this inverter, which is about 22 inches high and about 13 inches wide and about 8 inches deep, approximately, weighs about 74 pounds. So it's fairly hefty to move around. Most of the weight is down here at the bottom in the form of a large transformer. So in order to get it mounted on the wall, I had to lift it up there. Before I could actually mount the inverter, I had to prepare it for mounting. So what I did was screwed a piece of 1-inch plywood to the wall, and it's screwed in with large screws that go into the studs that form the structure of the wall. And then, because the inverter needs to be mounted on a fireproof surface, I put a layer of sheet metal, which in this case is galvanized steel, onto the plywood, so the inverter will be mounted on a fireproof surface. The inverter came with a mounting bracket. Over here you can just see part of it that is attached to the surface that the inverter is going to be mounted on, and then you hang the inverter on the mounting bracket, and there are 4 studs that stick out of that mounting bracket that have to go through holes in the inverter frame. So in order to mount it, you have to lift it up and get it onto the studs and then put the screws on while holding it up in place. In order to do that, I stacked up a bunch of stuff underneath it, put some of the packing foam that came with the inverter on top of what I stacked up, and then picked the inverter up and set it on top of the packing foam, and looked at the height, made a couple of adjustments to get it to just the right height so that it was supported by my blocks of wood and packing foam, and then slid it onto the studs. So the weight of the inverter wasn't an issue in mounting it because the weight was supported by the materials I set it on top of. And that, for making a solo installation of this inverter, was relatively important. So it went in pretty easily. The next step was wiring it in. And basically there are 3 places that you have to connect wires. The first place you need to connect is over here, where the DC power wires come in from your battery bank. And I just made up cables of the appropriate diameter, in this case 2-aught cables, and attach them. They're very simple. Just slide onto the studs and bolt them down, and then put plastic covers over the top. The more difficult thing to do, though, was to attach the AC out wiring and AC in wiring down here, because the connection points for that are inside the body of the inverter. There's a little panel on the lower left-hand side of the inverter down here that you remove and you get access to connection points. But you have to work through about a 3 by 3 inch opening, and some of the connection points are kind of difficult to get to. Now there are knockouts in the body of the inverter where you can bring cables in either from the sides or from the bottom. I don't know if you can see it here because of the angle of things, but I had to come in through the sides because I did make the bottom knockouts and tried to feed the cable through, but the knockouts are right down at the bottom of the inverter, and the bottom of the port that they have to go into is high enough that I could not reach down there to put the nuts that hold the strain relief fittings for the cables into the bottom of the inverter. So after trying to get that on there for maybe 20 minutes, I finally gave up because I simply couldn't get my fingers down in there. And it's not because I have particularly large hands. I have kind of medium-sized hands. If I had big hands, it would have been much more difficult. So I had to come in from the side, and that meant that after I came in, I had to bend the wires at 90 degrees and feed them into the connections. And that turned out, particularly for the AC in wiring, which is 10 gauge solid copper wire, which is rather difficult to bend, turned out to be rather tricky to feed the wire in and bend it and get it into the fittings. But I did accomplish it. It probably took 15 minutes though to connect 3 wires. And then the ground, which was quite easy to connect. The AC out wiring is a flexible cable. I just used a cable that for a generator because it had the right end on it to go into my transfer switch. And that's flexible wire, so it was much easier to put in, but still not that simple. It's also number 10 wire. And the final connection for electrical power was the ground wire here, which is a number 6 ground. It comes down and is attached to a ground stud on the case. And that was pretty easy to connect. And other than that, the only other connection that I made was here, and this is the temperature sensor for the batteries. And it just plugs in right here and then goes down into the battery box where it is attached to the side of one of my batteries. So that was pretty simple, and that's basically everything that you need to do to connect it. Now, of course, I had to run the AC out up into my transfer case, but that's easy to do. I just have to plug it in like this, and that's in. The AC in goes from the inverter into my circuit breaker panel, where I installed a dedicated 2-pole 30 amp circuit breaker so that I can run the battery charger function on the inverter and also use the inverter to pass power through to my transfer switches up here. So that's that. Now let's come down to operating the inverter. This inverter is pretty easy to operate. The first time you turn it on, you have to wait for it to come on and go through its test functions and then enable inverting. However, once you've done that, it retains that information. You don't have to enable inverting again. It stays on until you turn it off. Now, to turn it on, I just have a switch down underneath here that I turn. You can see it comes on, it runs the fan, goes through some tests. And I think if you heard that click, that was the inverter coming on. So now it's working. The little LED here indicates that the inverter is enabled. Unfortunately, that's about all you can do with the controls on the system, is turn it on and enable or disable the inverter by pressing right here. Or if it has a fault, you can reset and clear the fault after you have hopefully found out what was causing it and repaired it. But other than by counting flashes of an LED, you have no way of really knowing what the fault was. Now this is something that I'm a little disappointed with, is the lack of controls from the front face of the inverter. I bought this inverter partly because it has a lot of flexibility in terms of things you can control on it. For example, for battery charging, you can set it up for a specific battery bank capacity in amp hours. You can set up all the details of charging for the particular kind of batteries you have. You can either use default charging parameters, or you can customize them to whatever values you want. And you can also set a lot of other functions, like there is an energy saver function that will essentially, when you're running the inverter, will shut the inverter off and periodically check to see if there are any loads, and if there are, it will turn back on. That cuts down the power draw of the inverter in standby to something like 8 watts from its normal 41 watts, which is about what it's drawing right now to be in inverter mode with no loads, which, since I don't have any of my switches up here on my transfer switch turned on, there are no loads. So it's just 40 watts, which incidentally I will turn off so that I don't consume unnecessary power. The way the inverter comes as a standalone item, you can't enable different battery charging parameters. You can't set the size of the battery bank. You can't limit the charging current. You can't turn on or off the power saver mode. And there are a whole bunch of other functions that this has that you can't access. And that's something I didn't realize when I ordered the inverter. I should have read the manual a little more carefully, because to access any of those functions, what you have to have is the external control panel, which plugs in right up here and gives you access to all of the functionality of the inverter. So one of the reasons I bought this inverter was the price. It was about $1,250, which is relatively inexpensive for a UL listed 4 kilowatt split phase inverter. So basically, price was a big factor. And had I known I was going to have to spend another approximately $200 for the control panel to access the full functionality of the inverter, I might have bought a different inverter that I could operate without spending that extra $200. Now, I have not yet bought that control panel. Without the external control panel, I can't change anything from the default settings. And that's, from my point of view, a little bit important, largely if I use the charger functionality of this. The default settings for this are a 90 amp charge rate, and it assumes that you have a 250 amp hour battery bank. Now, I actually have a 400 amp hour 24 volt battery bank that this is connected to. So 90 amps as maximum charge rate is about 0.23 C for a charge rate, which is a little higher than I'm happy with. I'd like to run at about 0.15 C. So it'd be nice to be able to change the battery bank size inside the inverter to 400 amp hours and to set the charge rate to a maximum of 60 amps. That will protect my battery bank from potential damage due to charging at too high a charge rate. So that's something I'd like to be able to change. And there are a whole bunch of other parameters that would be nice to have access to, but they aren't absolutely essential. Now, how well does the system work? So far, I have run it a number of times It is a backup power system for power outages, so I don't run it continuously. And it seems to work really well as an inverter. In particular, I like the pass-through function. What that function allows you to do is, if I turn on the circuit breaker so that I have AC power going into it, and then turn on the loads that I want to power from the inverter, they'll be powered off of grid power until the power goes out. And when the power goes off, the internal transfer switch in here will switch from grid power to inverter power. And it only takes something like 15 or 20 milliseconds, it's less than one AC cycle, to make that changeover. And the result is that pretty much everything I've tried so far doesn't even notice the changeover when you go from grid power to inverted power off of the battery bank. And that's convenient if we are having a big storm and it looks like we're going to have a power outage. I just come down here, turn AC power into the inverter on, turn on all the loads that I want to potentially run off the inverter during the power outage, and everything operates completely normally. And if the power does go out, the inverter will change over so quickly that we won't even notice that there's a power outage, unless we're using a component that is not connected to the inverter. And there are a number of things in the house that aren't connected. So that's how it works. That's a really nice feature. I've tested it, as I said, and it works really well. And then when the power comes back on, once the inverter decides that it's good power, which takes about a minute or so, it will automatically turn the inverter off and switch everything back to grid power. So I don't have to, at that point, come down and do anything to the inverter after a power outage if I don't want to. And when it goes back to grid power, it will also turn the battery charger on and recharge the batteries. And I've done that a couple of times, and the battery charger is a very good battery charger. I really like its functionality and where its defaults are set. Works pretty well for my lead acid battery bank. But as I said, I'd like to be able to customize it a little bit to get the proper size for my lead acid battery bank, and also the maximum charge rate set to what I think is a more appropriate value. So other than the lack of access to its full functionality without the $200 external control panel, I am very happy with how this inverter works, and seems to be have been a good choice. There is one other feature of it that is was a bit of a nuisance, and that is they would like you to register this inverter online after you buy it. And in order to do that, they'd like a picture of the installation, and they would also like a picture of the inverter data panel, which is over here on this side. Now, I didn't know that until I went to register it after I had installed it. And it was very difficult to get a good picture of this panel in here because there just isn't a lot of room. I did finally manage to get my phone in there and push the button to take the picture. But it was a little tricky to get a good picture that showed all the information that they want. So if you buy one of these, I have a couple pieces of advice for you. One, take a picture of this plate over here, data plate for your particular inverter that has the serial number and everything, before you install the inverter, so that you can do that easily. Also, do the AC wiring for the inverter before you install it. Yes, you'll have some wires hanging around that will make it a little bit trickier to do the install, but it will be a lot more pleasant to do that than to have to work in a potentially cramped area where you really can't see what you're doing to attach the wires. So those are two recommendations I would make. And if you want access to the full functionality of the inverter, you're going to have to bite the bullet and buy the external control panel, because I just can't see any way to get access to it other than that, except to buy some of their other external control functionality. It can be hooked up to the internet, for example, or you can hook it directly to a computer. But those interfaces all cost more than the external control panel. So one of those things you're going to have to buy if you want to access the full functionality of the inverter, which is actually quite comprehensive. So that's my Schneider Conext SW 4024 4000 watt 24 volt split phase output inverter. Overall, after 2 months, I'm very happy with it. It does everything I wanted it to, and it's easy to use, and as I said, I'm very happy with its operation so far. Now, if I was going to rely on AC power to recharge my batteries, then the battery charging would be quite an issue, and I would probably have to bite the bullet and buy that external control panel. However, my primary charging source for my batteries is solar, so that isn't such an issue. So anyway, that's where I am right now with this inverter, and some of the details about it, about installing it and operating it. As I said, I'm quite happy with it so far, but I've only had it a little over 2 months. So as we move on, I'm going to be looking in my next video at my solar charging system, the panels, the charge controller, and the battery monitor that I bought, talking about those systems and their functionality. And then I'll do a video and talk about the transfer switch that I bought. And finally, we'll do a video on the battery bank. And I think I'll do one other video, a short one, on some of the extra stuff that's necessary to set up this kind of system. Various bits of wiring, wire sizing, switches, fuses, circuit breakers, etc. Okay, thanks for watching. Hope you enjoyed finding out what my experience with the Schneider Conext SW 4024 split phase output 4000 watt inverter was. And if you did, give me a thumbs up. And if you haven't, don't forget to subscribe to my channel and click that notification bell so you'll be able to find out when my next video is up. Okay, thanks for watching.